Hi there, and welcome to this film about the structure of the atom. Hopefully you're coming to it, having watched the film about matter not all that long before. That film talked quite a lot about the way that we can look at what kind of atoms are present in a substance to decide what kind of substance it is. This film actually looks about what those atoms are made of, and it's a bit shorter, and hopefully quite a lot of it is revision for you, but it's got some really important points which are just absolutely vital to know for years 11 and 12. Okay, and hopefully by the end of this film you'll know the names of all the different subatomic particles, so that's particles that are smaller than atoms. You'll know where in the atom you can find them, and hopefully you'll also know what their relative mass and charge are. Okay, well here's a diagram of an atom. It's just one of many, many ways of representing atoms, but what all those ways have in common really is the fact that there's a nucleus or a center to this atom, and within that nucleus is where you'll find two of the subatomic particles, the proton and the neutron, and they're by far the heaviest particles in the atom, and they're stuck there in the middle. And this diagram's nowhere near to scale, but what it attempts to show you is that the electrons, and that's the third subatomic particle, and we only need to know those three for chemistry in years 11 and 12, they're orbiting the nucleus, and this diagram kind of shows them in quite neatly defined paths, but we know now that that's not true. Their motion is very random indeed, and it's actually quite difficult to comprehend, being governed by quantum mechanics, which are difficult things to comprehend. But anyway, there we are. That's the structure of the atom. Well, let's just quickly look at the properties of those subatomic particles, and the most important properties as far as we're concerned are their mass and their charge. They're relative quantities, right? So they don't have units, right? They're related to other things. They're actually related to a 1/12 of the mass of a carbon-12 atom. Okay, so if a proton has a relative mass of 1, it means that its mass is exactly 1/12 of the mass of a carbon-12 atom. Okay, it doesn't really matter too much at this stage what they're relative to. Okay, but as we can see here, the mass of the proton and the neutron are pretty much the same, rounded to the same number here, and the electron is much, much lighter than both of them. Okay, the electron's got a mass of only about 1/2000th of a proton or a neutron, to be more precise, about 1/1850th. Okay, so next to a proton and a neutron, an electron's absolutely tiny in terms of its mass. Okay, as far as their charge goes, again, this is a number without units because it's relative, and it's all relative to the mass of a proton. So to the charge of a proton. Anyway, we've got a +1 charge for a proton, it's positive. We've got no charge at all for a neutron, neutral in other words, electrically. And an electron, well, that's got exactly opposite but the same amount of charge as a proton. So it's got -1, but it's negative. Okay, and just finally, this final column of the table just talks about what we talked about on the previous slide, that these two subatomic particles, the proton and the neutron, they're found in the nucleus, and therefore they're called nucleons. Okay, whereas the electrons are orbiting around the nucleus, and we'll see later that they're orbiting in different energy levels, which we call shells. Okay, but that's about it for this film about subatomic particles. If you're thinking what film should I watch next, it's probably a good idea to watch the one about atomic symbols, which tells us how the subatomic particles we've been learning about can be represented using a simple notation.